Okay, today we're going to talk about basic property of two-dimensional figure. So let's start with trapezium. Now, when you have a trapezium, the thing is these two sides are parallel, so we can see that the gradient must be the same. As for parallelogram, right, we know a parallelogram must be such that the midpoint of these two, this diagonal here, right, and this diagonal over here must be the same, which is at point E. Okay. Now, another thing is, of course, that the distance AB must equal to DC, BC must be equal to AD, and the gradient must be the same. Now, it's actually the same as a trapezium. The only difference is the midpoint of the diagonal. Okay. All right. Then rhombus. Rhombus is actually similar to a parallelogram. The difference is again the diagonal are perpendicular at the center here, right? So you can see diagonal perpendicular. So when you multiply the gradient m1 to m2, the result must be -1. Okay, how about rectangle? Rectangle is actually a type of parallelogram, but it's perpendicular at the edge here. So we can say that gradient ABC equals to DC, gradient AB equals to AD, and so on. Okay, a square is actually a form of a rectangle that is perpendicular at the center here, the diagonal, right? So it actually has a similar property to rhombus as well as rectangle. Yeah. Okay. Now, how about kite? Well, kite is actually a rhombus but just elongated. A rhombus is something like that. But kite, one end is actually longer. But main thing is the diagonal again are perpendicular at the center. Okay. So I think enough for now. We'll just look at one example. Example number 25. So in this diagram, ABCD is a rhombus where D touches the x-axis and E is the intersection between the two diagonal. Given equation of straight line BD is x plus 2y equals 7, find equation straight line AC. Now, one thing we know straight away from BD, right? We know BD is x plus 2y equals 7. It is perpendicular to AC. Okay? So if it's perpendicular, 90 degree here. So again, we have two ways, the standard way and the fast way. Actually, the standard way first. The standard way is we change this equation to y equals to mx plus c, so that my gradient of BD is -half. As for AC perpendicular, so CD, BD plus AC must be -1. Gradient of AC is just +2. And since AC passes through point A here, when you form the equation y minus y1, we have to use coordinate point A. Your y1 is 7, gradient is 2, x1 is 8. So when I expand, I get 2x minus 16 plus 7, y equals to 2x minus 9 here. Okay, so that is the equation of AC. Now you can also use the method I taught you guys, interchanging your x and y. The coefficient of x here is actually 1. Coefficient y is 2, so I switch the position, it becomes 2x and y. The plus sign change to minus. You let this be c. When you sub 8 and 7, my c is 2 times 8 minus 7, which is 16 minus 7, which is 9. So therefore, your equation is 2x minus y equals to 9. Yeah, notice they are actually the same. This answer, they are actually the same. So I've got equation AC with D. So next thing is we're going to find coordinate point E. Now we know AC and BD, they do intersect each other at point E here. So to find E, we just solve them simultaneously. You can call this equation 1, call this equation 2. Let's say this is part A, part B. I sub equation 2 inside equation 1. So I'm going to write x first. So yeah, I'm going to write x first plus 2y. Y is 2x minus 9. The result is 7. So this is x plus 4x minus 18 equals 7. 5x is 25. X is just 5. So once I know x value, we can just sub inside equation 2 to find my y value. So my y is 1. So E is 5, 1. Okay, how do you find coordinate point C? Now we know E is the midpoint of AC. So we're going to let C be xy. So E equals midpoint AC. So I will say x plus 8 over 2 equals to E, which is 5. Y plus 7 over 2, which is 1. So x is now 10 minus 2, minus 8, which is 2. Y is 2 minus 7, -5. So therefore, your coordinate of C is 2 minus 5. Okay, next, how do I find area of rhombus? Okay, now area of rhombus ABCD. You don't have to find all the points. We just need minimum 3 points. Since I already know C, right? I know C is 2, -5. I know A, I need to find D. And D you can find easily because from equation 1, we know your x-intercept, right? At x-axis, y is 0. Yeah, from equation 1 here. So your y is 0, x is just 7. Okay, let me highlight to you again. Sorry, I'm going to use a different pen. Yeah, there you go, equation 1. Because line BD intersect the x-axis at point D. So my x is now 7, so D is 7, 0. And to find the area, we use what? Half times. I don't, like I said, I don't have to use all the coordinate. I just find area of this, sorry, different color. Area of this triangle, then I times 2. I'll get the whole rhombus, right? My triangle, I'll use half. Let's say I use point ACD. You can use any other direction. I'm going to use ACD. A is 8, 7, C is 2, -5, and D is now 7, 0. Repeat point number 1. Okay, but you got to times 2. Remember, times 2 because I'm finding the whole rhombus. So the 2 can cancel the 2 here, so I think I don't need to write that anymore. I just have to multiply these numbers. This is what? -40, 0, let it be. This is 49. You minus this way, but this is 14, -35, and 0. Okay, I need you guys to calculate. This is 9 minus 21, minus 21, 9 plus 21, answer 30 square units. Okay? Okay, for self-test 27, diagram shows PQRS, and T is a diagonal, intersection between the diagonal, so it's a midpoint of the two diagonal. So equation straight line SQ is given. We are finding equation straight line PQ. Okay, before you find PQ, we need to find PS first, because PS and PQ, they're perpendicular. Now, I hope you know by now, whenever they're perpendicular, we know we're going to do M1 dot M2 equals -1. But first, I need to find gradient of PS. And since I know P is my y-intercept, X, my S is my x-intercept, so we can use negative y-intercept over x-intercept, we get 4. Now, gradient M1 dot gradient M2 is -1. So gradient PQ is now -1/4. And for me, in this case, I wouldn't use y minus y1, mx minus x1, because I know my y-intercept. My y-intercept is 4 at P here. So I'm going to use y equals to mx plus c. This is equation of PQ. Yeah, it's easier that way. Now, how do you find coordinate point Q? Well, I know equation straight line P, what do you call that? SQ. SQ is this, 9y equals to 2x plus 2. Okay, and this equation is y equals to -1/4x plus 4, right? So I'm going to solve them simultaneously. Yeah, this is equation 1. This is equation 2. So, okay, I'm going to call this equation 1 here. I'm going to write down here 9y equals to x minus 2 plus 2 equation 2. I'm going to sub b 1 in 2. So the moment you sub inside, don't write y, write -1/4x plus 4. This is 2x plus 2. Okay, I'm going to times inside 1 by 1. Do a little bit slower for all of you. Okay, and if you don't like fraction, just multiply by 4. When you times 4, this is 144. This is 8x plus 8, right? Bring over 17x, 136. 136, can divide, right? 136. You get 8. 136 divided 17 is 8. Okay. Now with that, I need to sub inside, let's say, equation number 1. Y is -1/4 times 8 plus 4. Answer is just negative, just +2. Yeah. So coordinate point Q is 8, 2. Okay. Next, C. How do you find coordinate of point T? Okay. Now T is the intersecting point between these two diagonals. So we already know Q, 8, 2. We already know S, -1, 10, 0. We can find T. So T is the midpoint of these two. So -1 plus 8/2, 0 plus 2/2. Answer 7/2 and 1. Okay, all right. So no problem. And how do I area rectangle? Well, for rectangle, right, we know this is my triangle, which is times 2. Don't need to find coordinate point R. No point doing that, right? So just take the area times 2. Okay, so let's do this. Area equals to, I'm going to use PSQ. You can use PQS, up to you. Yeah. X1, Y1, X2, Y2, X3, Y3. Repeat point number 1. Whatever you get, times 2. And the half and 2 can cancel out. This is 0. This is minus 2. This is 32 minus this way up, negative 4. The rest are all 0. So it's 32 plus 32 minus 2 is 30. 30 plus 4, 34 square units. Okay? Okay, this is example 28. You have a rectangle ABCD on Cartesian plane. You're finding equation of straight line BC. Now, we've done this many times. We know that AB and BC are perpendicular because it's a rectangle. Always start by finding the gradient of AB first. I'll use y2 minus y1, x2 minus x1. 6 divided by negative 2, I get negative 3. Now, and then we know they're perpendicular. BC and AB are perpendicular. Gradient AB times gradient BC must be negative 1. Gradient BC should be positive 1 over 3. And the form equation straight line, I can use what? Y minus y1. Guys, my y1, I'll use this point, 1 over 3, x minus x1 is 2. So 3y minus 3 is x minus 2. 3y is x plus 1. So this is equation of straight line BC. Okay, next thing is area of triangle ABC. Now, triangle ABC is this. So remember, if you use clockwise, it's going to be negative. Anti-clockwise is positive. So I'm just going to use anti-clockwise to make it easier. Okay, later on, we don't have to consider plus minus. We know we have to take, it's just a positive value, right? Because I'm taking this direction anti-clockwise. A is 0, 7. B is 2, 1. C is xy. Repeat the first point. So this is going to give us half. This is 0, 2y, 7x minus, this is 14 and x. Okay, if I simplify this, maybe I write x first. 7 minus 7 minus x is 6x. 2y minus 14. When you divide by 2, is 3x plus y minus 7. Alright, there you go. That's your area of triangle ABC. Well, C. Find the value of x and y if the area rectangle. Be careful, this is not triangle, is rectangle. Rectangle is 20. Now we know the rectangle is double the area of triangle. Maybe I highlighted for you. This is your maybe half of it, right? It's double. So if your area rectangle is 20, area of triangle should be half of 20, which is just 10. So we can straight away say 3x plus y minus 7 is 10. Here we may make y as a subject. Y is now 17 minus 3x. Okay, I'm going to call this equation 1. I'm going to call this equation 2 of y, because the x and y is your x coordinate point C, and it must fulfill both equation. It must satisfy both equation. The first equation is BC because it lies on line BC. Number 2, it must satisfy the second equation here because area of ABC is now 10. So by solving 2 in 1, solve them simultaneously, I will be able to find coordinate point C. Sub inside. So 317 minus 3x equals to x plus 1. 51 minus 9x equals to x plus 1. So 10x is 50, x is just 5. Okay, so once you know x equals 5, we can just sub inside, let's say, equation 2. My y is 17 minus 3 times 5, which is 2. So C should be 5, 2. Okay, now coordinate point E, which is the midpoint of AC. This is the easiest, I would say. The first 3 parts a bit more difficult. E is the midpoint. So I know point A, I know point C. E is just 0 plus 5 over 2, 7 plus 2 over 2. Answer is 5 over 2 and 9 over 2. Okay, that's all. Okay, let's look at self-test 28. The first thing I need to do is to find equation RS. And this is quite similar to the question earlier. You can see that QR is perpendicular to RS, so this is 90 degrees here. So let's start by finding gradient of QR. I'll use y2 minus y1, x2 minus x1, negative 2 for QR. Now for RS, m1 dot m2 RS, the result is negative 1. gradient RS is just 1 over 2. And to form equation straight line RS, I have to use point R here, minus 2, 0, y minus y1 equals to mx minus x1. So when I times inside, I get half x plus 1. Okay, so this is equation straight line RS. I'm going to use this equation later. I just name it equation number 1. Okay, the second part, how to find coordinate point S. And now you notice S is the intersection between line TS and RS. Line TS is 7y equals minus 3x plus 46. So this is TS. We call this equation 2. As I sub 1 in 2, my y is now half x plus 1 equals minus 3x plus 46. Multiply the 7 inside. Okay, now if you don't like fraction, just multiply by 2. This is 14, it's minus 6x and 92. So when I bring over, this is 13x, 92 minus 14 is 78. 78 divided by 13 is 6. Then we sum inside equation 1. My y is half times 6 plus 1. Answer is 4. So my coordinate of point S is 6, 4. Okay, now next part C, I want to find point U. Okay, so U is a point in between such that RU, US, the ratio is 3 to 1. This is 6, 4. So we can say that U is n times x1, 1 times minus 2, 3 times 6, n times x2. Remember, the ratio and the coordinate must be opposite. Total ratio 3 plus 1, you can just write 4. And then 1 times 0, 3 times 4, total ratio 3 plus 1. So here you have 18 minus 2 is 16. 16 divided by 4, you still get 4. 12 divided by 4, you get 3. Okay, part D. Find the coordinate point T if area of quadrilateral QRST is 35. QRST is 35. Okay, so to use area of quadrilateral, I suggest we use anti-clockwise RSTU this direction. So area is half x1 y1 x2 y2. T is an unknown, so I'm going to call it xy. And RQ is minus 4, 4. Repeat the first point. Result is still 35. Okay, since I already used anti-clockwise, so you don't have to treat this like a modulus. Don't have to consider plus minus. Just calculate only. This is minus 8 plus 6y, then plus 4x. The last one is 0. This is 0 as well. Minus 4x minus 4y minus 8. 35 times 2 is 70. So when you put it together, notice that the x will cancel each other off. 6y minus minus 4y is 10y. Minus 8 minus minus 8 cancel as well. My y is just 7. Okay, if your y is 7, we can just sub inside, let's say, equation number 2, y. Because point T actually lies on this straight line, 7y equals minus 3x plus 46. So if I sub inside equation 2, I can actually find my x coordinate. My y is 7. My y is 7. So 7 equals negative 3x plus 46. So bring over 3x is negative 3, right? Yeah, x is just negative 1. So my coordinate point T is just minus 1, 7. Okay? Okay, guys, now let's move on to locus. Locus is something that we've done in Form 2, but in Form 3, KSSM Syllabus Form 3, you learn about the idea of a moving point. So now, and in Form 3, you learn about drawing only. This we don't really need to know how to calculate from the equation. So now, the first locus that you need to know is the constant distance from a fixed point. So let's say, imagine this. I always tell the story about, if you tie a dog to a chain, the dog will actually run to the end of the chain and unbark whenever you see a stranger, intruder, things like that, right? So now the range of movement of the dog is actually restricted to the length of the chain. The dog can only go in a circle like this, as you go around, because this is the maximum distance it can travel, it can move, right? So if let's say you have we model the position of the dog, with coordinate xy, and A is your fixed point, maybe the pole here, all right, and the chain is, let's say, has the length of k. So we know that the distance of A to P, P is a fixed point, P is a moving point, A is a fixed point, is constantly k unit. Yeah. So by using formula for distance, we sub inside x minus x1 square plus y minus y1 square root the result k, expand it, you get equation locus in this form. Yeah, we call this an equation of circle, x squared plus y squared plus ax plus by plus c equals 0. Generally, it's in this form. Okay, so maybe I show you one example. It's not difficult at all. So we know that P is a moving point xy. So AP in this case is constantly 3 unit. So we use a formula for distance x minus 1 square. Your x1, y1 is 1 and minus 2, y plus 2 square. The result is 3. So when I square both sides and expand this, x squared minus 2x plus 1, y squared plus 4y plus 4, 3 squared is just 9. So when you put them together, right, this is 5 minus 9. 5 minus 9, negative 4. So this value is negative 4. Yeah, that's all. Just leave an answer in this form. Will do. Okay, self-test 29. So now distance PB is 5. Now B is a fixed point, P is a moving point. So we use x minus 2 is x plus 2 square, y minus 3 square, put the square root over, the result is now 5. So we shall just expand both sides. Okay, y square 6y plus 9, 5 square is just 25. So put it together, x square plus y square plus 4x minus 6y, 13 minus 25 is negative 12. There you go. That's your answer. All right, the next one is equidistant from two fixed points. I always use a story about, a boy who wants to, want to go to Teliti tuition or a cyber cafe. Yeah. So since we have a number of cyber cafe in our area here, so this is a boy. So his distance, he's at the crossroad. He doesn't know whether he wants to go to tuition or Ponting and go to cyber cafe. So the distance here is always the same. So as he walked along the road, he was thinking, okay, should I go Teliti tuition or should I go cyber cafe? As he kept walking, he couldn't make up his mind. He kept going. The distance is constantly the same. Yeah, and he kept going and going, and he just went home. Right? So now, the position of the boy can be modeled by this coordinate xy here, and let's say the institution is A x1 y1. The cyber cafe is B x2 y2. So the distance is always the same. So we can say AP equals to PB. And remember the formula for distance is x minus x1. Now x1 is a coordinate point A here. Then y minus y1, you square it, put the square root over, the result is equals to x minus x2 square plus y minus y2 square. So when you expand and you cancel this, you expand, simplify, you always get the equation of straight line, because this line is what we call, there's a name for it, what do you call that? It's a perpendicular bisector. In fact, you can actually use a formula for perpendicular bisector to do this. Yeah, we will learn how to form equation perpendicular bisector given 2 points. The end result is the same, but I feel this method is faster. Yeah, the coordinate, this locus method, yeah, is faster. Okay, let's look at one example. Example 30. Your point C and D, you're finding equation locus such that PC equals to PD. Now, again, P is xy, so we say x minus 2 square, y minus 0 square. The distance must be x plus 4 square, y minus 3 square. But I should put a square root over it. But when you square both sides, the square root will be cancelled off automatically. Yes. Sorry, I made a mistake here. This is supposed to be a 4 minus 4x. Then it's a y square. This is x square plus 2ab will be 8x. B squared is 16 and y squared 6y plus 9. So we can cancel x squared and y squared. Left with minus 4x plus 4. This will be 8x minus 6y plus 25. Okay, let's just cancel them directly. I hope you can see that. Cancel this and this, cancel this and this. It's so much faster. So when I bring over this, will be 12x minus 6y plus 21. And normally, if you can simplify, you should simplify. I think I should not stop here. I'll just divide by 3. So 4x minus 2y plus 7 equals 0. Now this is in the form of equation straight line in general form. Okay. Okay, self-test 30. So here we have a locus of moving point P such that it's equidistant from A and B. So again, same concept. We're going to use AP equals to BB, square root x plus 1 square plus y minus 2 square. The result will be x minus 3 square, y plus 1 square. So when I expand both sides, we should get this y square 4y plus 4, x square 6x plus 9, y square 2y plus 1. Okay, cancel x square and y square, you get 2x minus 4y plus 5, 6x 2y plus 10. Bring the x over, 6x negative you bring over is positive 6, so 6 plus 2 is 8, minus 4 minus 2 is minus 6, 5 minus 10, negative 5. There you go, that's your answer. You can write any form, I just leave it as general form. Okay, the next one is constant ratio from two fixed points. Now, here it's a bit hard for me to use any example. It's more like a piston in your car engine, but I know some of you don't understand the piston motion in your car engine. So let's say we have a point P, X, Y. It moves such that the ratio from point A and B constantly m to n. So for example, when P is here, this distance here is m. Let's say the ratio is m. This ratio here is n. Yeah, P can be over here. The ratio from these 2 points must be the same. So P could be over here. The ratio from here to here is constantly the same. Actually, what we get is a circle, but we get a circle with a different center. The center is not A, the center is another point, let's say C. So what we have to do is we change from ratio to what we call proportion. Proportion is basically two equivalent fraction, and then from there we change to equation. Now this is opposite of what we've done earlier. In the ratio theorem, normally if they give you an equation, we're going to convert to proportion and change ratio so that we can figure out the ratio and use the formula nx1 plus mx2 over n plus n. Remember that? Now, this is the other way around. If you're given ratio, you write in the form of proportion, change to equation so that you can sub inside and form equation locus. And like I say, the final answer is always in this form, in the form of equation of circle. Okay, let me give you a simple example. Okay, example 31. So your ratio PA, PB is given as 1 to 4. So maybe I write PA over PB 1 over 4, right? Right in proportion. When we cross multiply, 4PA is now PB. What's your PA? We use x minus 1 square, y minus 0 square. The result equals PB. PB is x minus 2 square plus y minus 3 square. So when I square both sides, 4 square is 16. This is x square. Expand is x square plus 2x plus 1. You have a y square here. This is x square minus 4x plus 4. This is y square plus 6y plus 9. So as I multiply inside 16x square, 16y square minus 32x plus 16 equals to x square plus y square, 4x, 6y, and 13. Now 16 you minus 1 left with 15. 15x square, 15y square, 32 minus 32 plus 4 is minus 28. Then you minus 6y, 16 minus 13 is just 3. Now, we cannot simplify this equation because everything, don't think you can divide with anything, right? Yeah, so you can't divide it. So there you go, we just stop here. This is your final answer. Okay, self-test 31. P is a moving point such that the distance from point Q and R in the ratio of 2 to 1. So we can say PQ, QR is 2 to 1. PQ over QR is 2 over 1. So PQ is 2 times of QR. Okay, now next we should sub inside your formula for distance. PQ will be x minus 5 square plus y plus 1 square. Result is 2 times of QR. QR will be x minus 2 square, y minus 4 square. So when you expand both sides, this will be 10x plus 25. This is y square plus 2y plus 1. There will be a 4 here, x square minus 4x plus 4, y square minus 8y plus 16. So when you simplify further, x square plus y square, 10x plus 2y plus 26. This will be 4x square plus 4y square minus 16x minus 32y and 80. A little bit too long. So we transfer everything to the right. So 4 minus 1 is 3, 3x squared, 3y squared, minus 16 plus 10. So it's minus 6x. Minus 32 minus 2 minus 34, right? And last one, 80 minus 26 is 54. There you go. That's your final answer. Okay, right angle from two fixed points. So this is a bit, how would I say, not a common exam question, but yet they can test in SPM. Came out in SPM before 1997, you can see from here. So now, the first thing is, when you have a right angle, remember in Form 3, you learn about angle subtended at the center and angle subtended at the circumference. The angle subtended at the center is always double the circumference. So if this line is a diameter to a circle, then this angle is always 90. So rather than finding what they call that, some people go and find the distance first, distance of diameter AB, and then go and find the radius and then form equation, a constant distance using the first locus type. I think that is a bit long. I think this is easier. We know that if P is a moving point such that APB is 90 degree, right angle 90 degree. So we know if this is a right angle triangle, right? We can use the concept m1 dot m2 or m gradient AP times gradient PB equals -1. Use the formula for gradient times together, just rearrange it. You will always get the answer in the form of equation of circle. Okay, let me show you one example. Okay, now in example 32, ABP lies on circumference of circle with diameter AB. So we know it's confirmed right angle. So let's say this is A, this is B, B is somewhere here, this angle is 90 degrees. So we can say gradient of AB times gradient of BB equals -1. So we take y minus y1, x minus x1. You multiply with PB, y minus 0, x minus 3, results -1. So can we expand this? Y squared minus 4y. Or sometimes maybe I think it's better not to expand. So I tell you what, I don't want to show you, I don't want to expand first because I think it's better we rearrange it, because if I expand, a lot of things will move, a bit more difficult. And then I bring this over, x plus 1, x minus 3 plus y minus 4. Because if this is negative, right, when you bring over, everything else is positive. Only then I expand. Okay, and I simplify further. Minus 2x minus 4y minus 3 equals 0. Okay. Okay, self-test 32. Now, point Q move such that SQT is constantly 90. SQT is 90. Okay, so now what do I do? I know I can use gradient of SQ times gradient of QT, the results -1. So I use y SQ, y minus y1, x minus x1, QT, x, sorry, this is y first, y minus y1, x minus x1, -1. So I will rearrange first, negative x minus 2, x minus 4, bring over x minus 2, x minus 4, plus y plus 1, y minus 3, expand them. This is going to give us 6x and 8. This is 2y minus 3, and we just arrange it. I usually put x first, followed by y, 6x, 2y, 8 minus 3 is 5. The result equals 0. Okay. Okay, solving problem involving loci. So diagram shows triangle OLN where point M lies on LN. So P is the moving point such that the distance from point M is always 5 units. It's a locus. Distance from point M is always 5 units. We know it's a circle, right? Remember, that's the first case, constant distance from a fixed point. And LN lies on locus of P. So that means if LN lies on locus on P and P is a circle, that means it must be a circle that passes through L and N, something like that. Okay, I just do a rough sketch. So what can we tell? Ln must be a diameter of the circle. So to find equation locus, we can start by writing Pm equals to 5 units. Okay, use the formula for distance, x minus minus 2 square, y minus 4 square, the result is 5. So as we expand this, x squared plus 4x plus 4, yeah, this is y squared minus 8y plus 16, result is 25. Okay, rearrange x squared y squared, 4x 8y, 20 minus 5, 25 equals to 0. Okay, so this is your equation of locus of P. Okay, B. Now they say that L lies on the locus. Well, L has a y coordinate k. Now when the point lies on the locus, what we can do is we can sub in the coordinate negative 6k into the equation locus. So my left hand side must be the same as my right hand side. Okay, so when you expand 36, this is k squared, 24, 8k and 5. Rearrange. Okay, this is 36 minus 24 is 12. 12 minus 5 is just 7. Okay, so we can double bracket factorize. So k is either 1 or 7. Okay, but you cannot accept both answers. Why? If you look at the diagram here, now you look at the diagram, where do you think k should be? K is a number, it's a y coordinate between 0 and 4. You can see your y value, k is over here between 0 and 4. So since k is between 0 and 4, therefore k has to be 1. You cannot accept both. Okay, now next one, part C. How do you find coordinate point M? Okay, now we know by now if this is a locus, P is a locus of a moving point, it's a circle, and M is your center of the circle, L and K is your diameter. So we know that, let's say M is an unknown, we call it xy. We know L is -6 and k is 1. We know that M is basically the midpoint of Ln, right? And M is -2, 4. Ln are right, -6 plus x over 2, 1 plus y over 2. So we just compare the x coordinate, right? This will be what? -4 plus 6. Okay, I do a bit slower, like -4 here. X is just 2. And then 4 equals to 1 plus y over 2. 1 plus y is 8. Y is just 7. N is 7. Alright. Part C done. Part D. Area of triangle OLN. Okay, this is easy. Area of triangle done a couple of times, right? O first, 0, 0. L is -6k. K is 1. N is, what's the coordinate N? 2, 7. Repeat the first pointer. So when you multiply downwards, this is 0, minus 42, 0, minus this way up 0, and -2. So it's actually 44. You modulus it, 22 square unit. Okay, self-test 33. Diagram shows locus of P with center A intersect the x-axis at C and D respectively. Find the distance of AB. Okay, distance AB very simple. We use the formula for distance. AB should be 3 minus 1 square, 5 minus 2 square. Put the square root over 3 square plus 2 square square. It's going to be 13, root of 13. I think I'll just leave it as root 13. Okay. Second one, find equation locus of P. Now P is a moving point, okay, x, y. Alright, so the center is at A, but we know the radius is root 13, so we can say AP is constantly root 13. Take x minus 1 square, y minus 2 square, put the square root over root 13, square both sides, x square 2x plus 1, y square 4y plus 4, root 13 square is just 13. We rearrange it. Okay, for this will be -8 equals 0. So that's your equation of locus. Okay, how do you find coordinate points C and D? Well, CD is your x-intercept. Now we know at x-axis your y will be 0. By letting my y equals 0, I'll get this quadratic equation. We can double bracket factorize them, 4 and 2 minus and plus. So x is either -2 or +4. So, but we know C is on the left hand side of the y-axis, so C must be negative. The x coordinate point C must be negative. The x coordinate point D must be positive. So therefore C should be -2, 0, and D should be 4, 0. Okay, and finally area of triangle. Now, actually, you can use half x1, y1, x2, y2, x3, y3. But since I know this length, see, this is minus 2, 0. This is 4, 0. And this triangle here is actually isosceles because it's a triangle. These two are the radius of a circle, right? So this length is 6 units. So I think I'll just use half times base. Your base is 6, your height is 2. Okay, but let's say you can use half x1 by 1, x2 by 2, x3 3. Repeat point number 1, you can do that. You get the same answer. The area is still 6 square unit. Okay, this is example 34. So here we have a locus of P that moves such that distance from point A is constantly 2 root 5. So we are supposed to show that the equation is given by this. Yeah. So I think we can start by writing what AB equals to 2 root 5. So use the formula for distance x minus 1 square plus y minus 3 square. Put the square root over the result is 2 root 5. Okay, we just have to expand this x squared plus 2x plus 1, y squared 6y plus 9, 2 squared is 4, root 5 squared is 5. So x squared plus y squared plus 2x minus 6y. This will be 10 minus 20. Answer negative 10 equals 0. You can see the answer should be the same as the one given. Now, how do you know whether a point lies on the locus? Very simple. We sub in the coordinate. If we say that the point satisfies the equation, that means when you sub in coordinate of b and negative 3, 7, my left hand side should be the same as the right hand side. So let's put negative 3 inside your x and 7 inside your y. This will be 6, 7 minus 10. And now we can see this is 9, 49 minus 6 minus 42 minus 10. 58 is 58 minus 58, right? So it's 0, which is the same as the right hand side. So we can say B lies on the locus of B. Okay, C. Determine the equation of straight line AB. Now here I know that B is your point on the line. So A is the center, so B probably here. So yeah, so we can just form equation straight line. We know point A, we know point B. So I'm going to find gradient AB. Yeah, so 3 minus 7 over minus 1 plus 3. This is minus 4 over 2, negative 2. And to form the equation, I use y minus y1. You can use any point. I use this point A here. Y minus y1 equals to m x minus x1. So y is minus 2x minus 2. When you plus 3, bring the negative 3 over, is a plus 1 here, minus 2x plus 1. So this is the equation of straight line AB. Okay, how do you find the point intersection? This here, line A intersect locus of B for the second time, yeah, at point C. Find the coordinate at point C. So we know we can use, we can solve them simultaneously. This is equation 1, this is equation 2. These two line, the locus and the straight line, they intersect again, right? So we sub equation 2 in 1. So don't write y, write minus 2x plus 1 square root plus 2x minus 6 minus 2x plus 1 minus 10. The result is 0. So when you expand, this will be 4x squared, 4x plus 1, 2x here. This will be 12x minus 6 minus 10. Okay, when you add up, this will be 5x squared. 14 minus 4 is 10. And this will be negative 15 here. So when I divide everything by 5x squared, 2x minus 3, okay, double bracket factorize it, 3 and 1, 3 and 1 to get 2. So I should write plus and minus, so x equals to 1 or negative 3. Now, which answer should I take? I have two answers here, but we know point B, right? Yeah, point B is already given as this negative 3. So we can't take negative 3. We have to take x equals 1. So when you sub, let's say inside equation number 2, my y is minus 2 times 1 plus 1, negative 1. Therefore, C is supposed to be 1, 1. Is it so? 1, 1. 1, negative 1. Okay, but I have another way. Now, just now I actually did a sketch. And you can see from my sketch here, A should be the center of the circle. We know that it's a constant distance from a fixed point. So A should be a center. And B is a point that lies on the circle. Yeah, the locus of B is a circle, remember? So what we can say is that if C intersect the curve again or the circle again, BC should be your diameter. A should be your midpoint. So perhaps we can use this concept midpoint. We let C be xy. Sorry, this is a bit ugly. Let me just improvise on this. This is xy. A B is given as negative 3, 7. A is minus 1, 3. So we know A is a midpoint, right? So this is method 2 here. A equals midpoint of BC. So we can say x plus negative 3 over 2 must be negative 1. X should be 1. And then you continue with y. Your y plus 7 over 2 should be just 3. Y should be minus 1. Therefore, C is 1 minus 1. Two different methods, same result. So that's 43. So here we have coordinate of R and S are given and locus of P moves such that RPPS has a ratio of 3 to 1. So I think the first thing we could do is we should rewrite in the form of fraction. RPPS is now 3 to 1 or proportion. Yeah, fraction of proportion. So bringing the PS over, RP is 3 PS. Here we use a formula for distance. Now remember, P is a moving point, xy, so we use x minus minus 2 square, y minus minus 1 square. The result is 3 times of PS, which is x minus 2 square, y minus 3 square. So when you square both sides and expand this, I got x squared plus 4x plus 4. This is y squared 2y plus 1. 3 squared is 9. This is x squared minus 4x plus 4. Y squared 6y plus 9. So let's expand first. And I can simplify this side, the left hand side. X squared plus y squared, 4x2y plus 5. Expand this, 9x squared, 9y squared. 9 times 4, 36x. 9 times 6, 54y. I will take 13 times 9, which is 117. So rearrange it. 8x squared, 8y squared, minus 36 minus 4 is minus 40x, minus 56 minus 2y is 54, minus 2 is minus 56, 117 minus 5, 112. Now notice that this equation can be divided by 8. So when I divide by 8, x squared plus y squared minus 5x minus 7y plus 14. 112 divided by 8 is 14. There you go. This equation is the same as the one given here. All right. The next part. How do you show that P passes, the locus of P passes through point 4, 5? Now, similar to my example, I have to sub in the coordinate 4, 5 inside. My left-hand side will be x. X is 4 squared. Y is 5. You square it. Minus 5 times 4. 7 times 5 plus 14. Okay, this is 16, 25, 20, 35, and 14. Okay, 16 plus 14. I'll just think 16, 14, 20, 20 plus 25. Sorry, 30 plus 25. 55 minus 55, you still get 0. Right hand side. Yeah. Therefore, we can say locus of P passes through D 4, 5. Okay. Up to here, okay, right? Not that difficult. Now, next we'll find equation straight line ST. We got point T, I've got point S. Let's find the gradient. Gradient ST should be, I take T first, 5 minus 3, 4 minus 2, which is 2 over 2, which is 1. Then I use the equation y minus y1, my y1. Let me take point S, 3. Gradient is 1, x minus x1, 2. Y is x minus 2 plus 3 plus 1. So this is the equation of straight line ST. Now, the next thing is we want to determine the coordinate second intersecting point besides T, where ST between line ST and locus of B. That means I need to call this equation 1, equation 2, as I sub 2 in 1, x squared plus, don't write y, write x plus 1, square it, minus 5x, 7, your y is now x plus 1, plus 14 equals 0. We just have to expand and simplify this. This is 2x plus 1 minus 5x, 7x minus 7 plus 14 equals 0. Okay, as I add up, this will be 2x squared, 2 minus 5 minus 7 minus 10, and then 1 minus 7 minus 6 plus 14, which is just plus 8. So here we can divide everything by 2, and notice we have a quadratic equation that we can factorize. The factors are 1 and 4. My x should be 1 or 4, but please take note, they say this is point T, another point besides T, yeah, besides T. So T is 4, so x cannot be 4, yeah, T is 4, 5, so x is really 4. So we don't take that, we take x equals 1, we sub inside, say, equation number 2, my y is 1 plus 1, answer 2. So the second coordinate will just be 1, 2. Now, by the way, can we use the midpoint concept like your example? Answer is no, because previously we know that when they say constant distance from a fixed point, we know where's the center. Here we do not know the center. We know that the second locus, the locus is this. There's a point that lies on the locus, which is point T for 5. We know it will intersect this straight line. Where's point S? S is a point somewhere. We don't even know where is S, okay? So we cannot say it's a midpoint. It is not, yeah? So maybe the line looks like this. S could be, I don't know, inside here or inside here, not centered, certainly not the center. So we cannot assume, right? We cannot say that S is the center, it's not, right? So that's why you cannot use the midpoint concept for this. For example, earlier you can. This is a different case altogether because it's a ratio here, yeah? Okay, example 35. So here we have a trapezium PQRS with line PQ is perpendicular to line QR. So which intersect the y-axis at point T. So given the equation of PQ is y equals to, PQ is y equals to 2x plus 8. And the equation of QR is also given, but it's given in terms of unknown, x plus ky equals to 6. Yeah, this is x plus ky equals to 6. 2x plus 8. So we know they are perpendicular, right? So you're supposed to find the value of k. Now, if two lines are perpendicular, the gradient times together must be -1. So maybe I start with PQ. Y equals 2x plus 8. What is your gradient? Answer is 2. How about QR? You have x plus ky equals to 6. Maybe I make y as a subject, minus x plus 6. Y is -1 over kx plus 6 over k. So my gradient QR is -1 over k. Now, when these two you multiply together, maybe I move this up a little bit, yeah. When you multiply together, yeah, gradient m1, which is 2, times gradient m2, -1 over k equals -1. So k is just 2. Okay, so first part, okay, yeah, not too difficult. Right, now the second part, I need to find the coordinate point Q. Now that I know the value of k, right, we can actually sub inside. Maybe I will just call this equation 1, and this is equation 2. We will sub 1 in 2, including the k. We sub k inside. We got to solve them simultaneously here to find the coordinate point Q. So my x plus k is 2, y is 2x plus 8. The result equals to 6. So let us expand this up. For x plus 16 equals to 6. We can bring this over. Okay, so 5x is 6 minus 16, which is -10. X is just -2. All right, I've got my x value, so I just sub inside, let's say, equation number 1. So your y is 2 minus 2 plus 8. Y is just 4. So coordinate point Q is -2 and 4. All right, moving on. Let's look at part B. This is A Roman 1 and Roman 2. I've got K, I've got coordinate point Q. Now, given that QTTR has a ratio of 1:2, I need to find coordinate point R, but first we need to find coordinate point T. T is your x-intercept. I already know Q is -2, 4. T is your y-intercept of this straight line from equation 2. I know x plus k is 2, y equals to 6. To find your y-intercept, maybe I would say that y-axis, x is 0, or maybe you sub inside from here. Yeah, because we already know the y-intercept. Sorry, I already know my y-intercept from here. Maybe I highlight to you this one. My y-intercept is actually 6 over k, right? So my QR, right? My C is 6 over 2, which is 3. Therefore, T is 0, 3. So with that, I can use the ratio theorem which is t is given as 0. Maybe I call r is x, y. Okay, the x coordinate point t is 0. Remember, the ratio must be opposite. So maybe I show you nx1, mx2. The ratio and the coordinate must be opposite. We take 2 multiply with the x1, which is negative 2, plus 1 multiply with x. Total ratio is just 1 plus 2. You can just write this as 3. And then we move on to your, okay, let me solve this first, then I show you the y, because I may not have enough space. Times over x minus 4 equals to 0, x is just 4. Then we continue with your y coordinate. We take 3 equals to 2 times 4, 1 times your y. Total ratio is 1 plus 2, which is 3. Y plus 8 is now 9, y is now 1. Therefore, coordinate point T is 4, 1. Point R, sorry. R is 4, 1. Okay? Alright, last part. W is a moving point such that it's equidistant from Q and R. So if it's equidistant from Q and R, we can use equation locus here. W to Q equals to W to R. Okay, now remember, we already have R. R is 4, 1 now. So, and W is a moving point. Yeah, it's actually a perpendicular bisector. We let W be x, y. So use the formula for distance. X minus Q is minus 2 square, y minus 4 square. I guess I don't have enough space, but okay, I'll try to squeeze everything inside. This is x minus 4 square, y minus 1 square. Okay, so when you expand this, this will be x squared plus 4x plus 4, and y squared minus 8y plus 16. The result is x squared minus 8x plus 16, and y squared minus 2y plus 1. Well, we can cancel x squared and y squared, right? Maybe I show you here, cancel out x squared, y squared, y squared. We can put everything in one line. So this is, okay, I need to use a black pen. It's not working. 4x minus 8y plus 20 is now negative 8x minus 2y plus 17. Bring everything over to the same side. You get 12x minus 6y. 20 minus 17 is just 3. Now notice that this equation we can divide by 3. As I divide by 3, 4x minus 2y plus 1 equals 0. Alright, that's the answer. Okay, let's look at self-test 35. So here we have a trapezium, ABCD. Line AB is parallel to DC. Given ADC is 90, so equation straight line AB is also given. AB is given. P is a moving point such AB is fine, so find the value of K. Okay, number one, we know that these two are parallel. AB is parallel to DC, so gradient must be the same. So maybe I start off by finding the gradient of AB. 3y equals to 2x plus 7. To find the gradient, we just divide by 3. Change to y equals 7x plus c. My gradient AB should be 2 over 3. Now, as for DC, right, this is your x-intercept and your y-intercept, right? So my gradient of DC will be negative y over x. Yeah, negative y-intercept over x-intercept. Since they're parallel, we can just equate them. K is just negative 2. Pretty straightforward, right? Okay. Now, next, I want to find equation straight line AD. And AD is perpendicular to either DC or AB. Yeah, they're perpendicular, both lines. So we need to find gradient of AD first. So we can use M1, gradient M1 or AD. AB is 2 over 3. Multiply with gradient AD, the result is negative 1. So gradient AD is negative 3 over 2. Alright, to find equations of this straight line, now you don't have to use y minus y1 and bracket x minus x1. Why? Because you know your y-intercept. Your k is negative 2. Your y-intercept is negative 2, right? So we can just say AD has equation of y equals to mx plus c. That's all. That's your equation of AD. Okay, how do you find coordinate point A? Now, you can see that AD and BD, they actually intersect at point A. So to find point of intersection, we just solve this equation. Maybe I call this equation 1, AB, and AD equation 2, solve them simultaneously. We sub 2 in 1. So this is part C. When I substitute 2 inside, this is 3 minus 3 over 2, x minus 2. equals 2x plus 7. I multiply first, and okay, I wonder whether you can handle this. Okay, never mind. I do one more step. 2x plus 7. A lot of people don't like fractions, so I just multiply everybody by 2. That's what I got. Bring over 13x is negative 26. X will be negative 2. Right? And if x is negative, we can sub inside, let's say, equation number 2. Yeah, my y is negative 3 over 2 times minus 2 minus 2. This is 1. Yeah, so therefore your coordinate point A is just minus 2, 1. Okay, part C done. Part D. How do you find equation locus of P? Now this is simple because we know point A, yeah, P is a moving point x, y. So we start from AP equals to 5 square root of x minus 2 square, y minus 1 square. The result is 5. So when you expand both sides, okay, this is 25, rearrange it. There you go.